Hello. Today we're going to talk about chapter 24, paired samples and blocks. All right, so this is what you've been fighting to do the last two chapters, okay? The last two chapters were about two samples, okay, independent samples. This one is now when they're not independent, okay, when you can pair them. So when they come from an experiment, it's a type of blocking. When it's a type of observational study, it's a form of matching. So, you've seen this before with before and after treatments, okay? When it's the same person and you're measuring at like two different times, okay? Okay, so what is paired data? Well, you have to be able to recognize it. There's no test, all right? No simple test to just determine yes or no it is, but it can be determined based on the how, right? When you answer the W's way back in the beginning of this whole textbook, right? So, an independent independent two sample t-test would be like measuring the effects of a drug. 30 patients get a placebo and a different 30 set of patients get the medical treatment. Okay, you're comparing two different people. All right, a paired two sample t-test is when you're measuring the before and after. So on the same 30 patients, you give them the drug and you test them before the drug and then after the drug. Okay, so with paired data, you only want the differences. So you take your data sets, you have two data sets, and you subtract them, and that's your new data set, which is now essentially a one samples t-test. Okay, so that's what we're doing with paired data. Okay, so it's a paired t-test is just a one sample t-test for the means of the pairwise differences, or the average differences. Okay, and the sample size is now the number of pairs. Okay, because you don't have 60 individuals, you had 30 pairs. Okay, only one individual for each pair. And of course, there's always assumptions and conditions. Of course, we have to have the paired data assumption, so that's one of them. Then you have your independent assumption has 3, so make sure it's independent, make sure it's random, and the 10% condition doesn't have to be explicitly written, which means it has to be stated if it's an obviously small sample, okay? But keep that in mind on your larger samples that you want to put that down. Now, the third assumption would be your normal population assumption, so you want to make sure that it's a normal model. You can check that, of course, with a histogram or a normal probability plot. And now that the conditions are stated, we're ready to test the paired differences. Okay, whether those differences differ from 0. So your hypothesis would be your differences equal, usually, if not almost always, right, 0. And these are the formulas you would use for your paired t-test. Okay, so you have n is the number of pairs. You have your standard error. All right, so when your conditions are met and the null hypothesis is true, the statistic follows a student's t-model on the n-1 degrees of freedom. Okay, and then you use that to obtain a p-value. Okay, right? Hopefully this is all familiar, right? We've seen this before. All right, for our confidence intervals, all right, we can just use this formula, and this is our standard error. And the critical value t depends on your confidence level and your n-1 degrees of freedom and n pairs. Like I always say, so much easier to do with an example. So take a second, read this, pause it, put this in your calculator. Okay, once it's in your calculator, again, we are doing a paired sample. So go to your list and go up on list 3 and type list 2 minus list 1, right? Because we want the differences, okay? And the reason that we're doing list 2 minus list 1 is because we're doing after minus before. We want to know what the change is, right? Brandon is going from 83 to 79. We don't want to say plus 4. No, he went down 4, okay? So make sure you know how to type that in. So list 2, you do second 2 minus second 1, and then it fills it out for you. Okay, so that's how we can put the data into our calculator. Let's begin. So here we list our assumptions and our conditions. Okay, make sure you satisfy all those parts. Here we have our histogram so that you can see that it's unimodal, roughly symmetric, and you have your hypothesis. We assume that the difference will be 0, and we're checking to see if the evidence reduces pulse rates. So we're doing less than. All right, list out your math and go to your calculator. I'm going to go to the main screen. I'm going to stat tests, and we're going to do a t-test. Use the data from list 3. We want the mean to be 0, the differences to be 0. It came from list 3, and we want it to be less than. There we go. There's our p-value. There's our t. Okay, and then here you can draw your normal curve, and we can showcase that, what we found. Because it's this low, we reject the null hypothesis. There's evidence. And we want to find how much evidence, so we're going to do a confidence interval. Now this one didn't tell you exactly what confidence interval. Typically it's 95%. That's like default. Okay, so you do your, or you get out your calculator, and you go to stat tests, and, whoa, wait, where am I? Must have double clicked. Stat tests, we want to do an interval, so a t interval. Use your data from list 3 and a 95% confidence interval. And we check. Notice that's the same thing. So you can either do it by hand with the formula or using your calculator. And then make sure you write your sentence, right, in context. That's important. Okay, so let's talk about blocking. All right, if we wanted to estimate the mean difference between husband and wives, it's, for some reason, a lot of people want to make box plots and compare them side by side. That's useless. Okay, when you are doing a paired samples, you have to combine them, because look at this. If we look at it here, the wife and husband are roughly the same age. It looks like, oh yeah, that all matches up, nice and perfect. However, when we actually pair them together and find that difference in their ages, well, now we can see that it's not at 0, right? It's actually a little bit more closer to 2, okay, with some extremes. So pairing removes that extra variation that we saw in the side-by-side box plots, and it allows us to concentrate on the variation associated, okay, so with each pair. So a paired design is an example of blocking, okay? It removes extra variation, so it's a good thing. All right, so what can go wrong? Don't use a 2-sample t-test for paired data. That's wrong. Don't use a paired t-method when the samples aren't paired. Again, kind of sounds similar. Don't forget outliers. The outliers we care about now are in the differences. Okay, don't look for the difference between means of paired groups with side-by-side box plots. That's that last one we talked about. And this is everything you should have learned. So short and sweet, under 10 minutes. Hopefully that makes sense. If not, I'll see you in class.